everyone, welcome to Mindful Math. Today we're going to be going over some GRE problems. These problems are also very similar to problems on the GMAT. And in particular, we're going to be going over problems where we can pick numbers to make it easier to solve the problem. So this is useful because we're given answer choices. We can pick numbers to help us solve these complicated questions with lots of variables. So whenever you see variables in the answer choices, that should clue you that picking numbers is a good strategy. So you don't have to do this. There's always other ways to solve these problems, and I encourage you to try to solve in your practice, try to solve these problems in as many ways as possible, because that will help you choose the best way to do it on test day. It will also increase the connections and the different ways you can think about problems, so you'll be able to do it faster on test day and see these problems in many different areas. So these problems are in the description, so you don't have to worry about copying them down. So if you need to pause the video to write them down because you want to work through them, go ahead and do that now. But the first problem is, if a, b, and c are odd integers, which of the following must be an even integer? So again, on all of these problems, we want to identify what is the question actually asking. So we want to know which of the following answer choices must be an even integer. That means it will always be an even integer no matter what. So when we pick numbers here, we're going to be eliminating wrong answer choices rather than picking the right answer choice. So if we pick numbers and get an even integer, that's not necessarily the right answer choice because we need it to always be the case, not sometimes be the case. But if we get an odd integer, then we know that it cannot be the right answer. So a, b, and c are all odd integers, so we just need to pick odd integers for a, b, and c. And I always recommend pick the easiest one. So usually that means the smallest one. So we're going to say a equals 1, b equals 3, and c equals 5. So let's go ahead and go through our answer choices. And again, we're looking to eliminate incorrect answer choices. So a plus b plus c, well, 1 plus 3 plus 5 is 9. That is an odd, so a does not must be an even integer, so we know that a is incorrect. B is ab, which would be 3, plus bc, which would be 15, plus ca, which would be 5, and if we add those up, we get 23, which is an odd integer, and so we know that b is incorrect. For answer choice C, we have 1 times the quantity 3 plus 5, which is 8. So that is an even integer, so answer choice C might be correct. Because we do get an even integer. We need to check the other two because it doesn't necessarily mean it's always an even integer, but we know that that's an answer choice that could be possible. For answer choice D, we have A is 1, B plus C is 3 plus 5 minus 1. So we have 1 times 7, and that's an odd integer. And then finally, for answer choice E, we have a minus 2, which is 1 minus 2, which would give us negative 1, times bc, which would be 15. That would give us negative 15, which is an odd integer. And so we know that E is wrong and answer choice C is correct. And actually, a lot of test preps recommend that you memorize all of the odd-even rules. I actually think it's better to look at the odd-even rules and understand why they're true. So yes, when we multiply two odds, we get an odd. When we add two odds, we get an even. When we add two evens, we get an even. When we multiply two evens, we get an even. If you memorize those, that's great. That will certainly help you on test day, but it's much easier to think about why they're true. And actually, when I said earlier that we have to check all of the answer choices, that's actually not really true for odd-even rules. So that is true in general. When we have a must be true and we're picking a single case, we can't know that it's true for all cases. But for odd-even rules, it actually will be, because it doesn't matter which odds or which evens I pick, all of those rules will always hold true. So if I pick 3 odd numbers and I get an even number through this expression, it has to be that case for all the time that I pick 3 odds. Again, different types of problems, we would have to go through all the answer choices, but for these odd-even rules, I highly recommend you think about why they're true, and you can always just pick numbers, so you don't necessarily need to memorize them. No, there's a lot of other things that you feel like you need to memorize for test day, especially for the GRE. There's a lot of vocab and a lot of words, so if you want to spare yourself memorizing that, just pick numbers instead. All right, let's go on to question 2, and this is also in the description. And this illustrates a point about picking numbers. We always need to make sure that if there are any restricted numbers, any numbers that the question itself says cannot be used, like in this case, we had to have odd integers, so we had to pick odd numbers. In this case, we have for any x that does not equal 0 or 1, which means that when we pick numbers, we can't pick 0 or 1 as our numbers. So again, when we see those variables in the answer choices, that's a lot of work for us, that's a lot of algebra. We can pick numbers to make it easier. So since we can't pick 0 or 1, I think the next easiest number is to say that x equals 2. If you want to pick a different number, that's totally fine. You could pick -1, maybe that might be easier depending on how you like doing your calculations. So let's go ahead and pick x equals 2, so that gives us 2 squared plus 4 times 2 minus 5 over 2 squared minus 2. So if we simplify that out, we'll have 4 plus 8 minus 5, which is 7, over 4 minus 2, which is 2. So we have 7 halves. So that means that when x is 2, this expression is 7 over 2. So we need to plug in x equals 2 into the answer choices to see which one gives us 7 over 2. Now in this case, we definitely do need to pick every answer choice, test every answer choice, because it is possible that 2 of the answer choices will give us the same answer for a given number, but not for every number. So I know I said in the last problem that you wouldn't necessarily have to, but in most cases you do have to test every answer choice when you pick numbers. So we can do this pretty simply. When x is 2, 2 minus 5, you don't even have to calculate as long as you know, well, there's no denominator, so how could it possibly be 7 over 2? Same thing with 4 minus x, and same thing with 3x minus 4. Since we know we have an integer and there's no dividing, we know that we can't get 7 halves. So let's go ahead and check answer choice C. So 2 plus 5 over 2, that is a possibility. And if we check answer choice D, we have 1 plus 5 over 7 halves. 1 plus 5 over 7 halves. We can bring that 2 to the top and we'd get 1 plus 10 sevenths, which is not the same as 7 halves. So we would know that answer choice C is correct. So I hope that this strategy gives you another way to look at problems. If you wanted to do these problems differently, there are certainly many ways to do it, and I really encourage you to think about these problems mindfully. So rather than going into these problems, especially in practice, maybe on test day, if you know you have a method that's going to work, just go ahead and go with that method, even if you're not thinking very mindfully about it. You're already thinking a lot, so that's fine. But when you're practicing, try to think of these problems in as many ways as possible. So how would you do this problem without picking numbers? Well, whenever you see this kind of expression and the answer choices are simpler, you can think, well, I have to be able to factor it, because if I can't factor it, I'm not going to be able to cancel anything out. So I know that I have to be able to factor it so that I can cancel something in the numerator and denominator. So certainly you could go through factoring the numerator and denominator separately, but another way to think about it, well, if I know something's going to have to cancel, I know that the numerator and denominator will have to have something in common. And since the denominator is easier to factor, because the only thing to factor out would be an x, and you know that you can't factor out an x in the numerator because there's that 5 there, when you see that x and x minus 1, that actually will clue you that one of the factors in the numerator will have to be x minus 1, because that's what we're going to be canceling out. And when you do that, it might be a little bit easier to see that the factors will be x plus 5, x minus 1, and then when you cancel out your x minus 1s, you'll get our answer of x plus 5 over x. So there's no one right way to do these questions. If you're a math teacher, probably factoring might be easier because you do that all day, every day in your algebra classes. But for the rest of us, who maybe haven't factored in a long time, I taught math, but I still haven't really factored in about 10 years. If you're my age and you're not a math teacher, you probably haven't factored in about 15 years. So maybe picking numbers is easier for you. So if you have any questions about this, please post in the comments below. Please ask any questions that you have. If you have any types of questions that you want me to go over, I'd be happy to do that. And I hope you enjoyed this video, and we'll see you next time.